Good evening. The following presentation is for Continuous Assessment 2 in Masters in Cybersecurity, and it's going to be a presentation around real-time network graphing on protocol level with the concepts taken from network theory and situational awareness of the systems. In computer and network science, network theory is a part of graph theory where a network can be defined and represented as a visual graph of all the interconnected devices on the network. For network administrators, it is a powerful visual aid which helps to clearly understand and see the state of the network and have appropriate alerts notifying them that some unusual activity is present on their network. Network administrators can use various network scanning tools which fall under two categories, which are active and passive scanners. Active scanners usually require quite a substantial amount of time to gather all the information of the current network and the devices that reside on it and the services running on their ports. Timing is very crucial in this state as it might be already too late to spot potential threats while the active scanner attempts to complete the network scan. Whereas passive scanners silently examines the network traffic flow and extracts all the relevant information from it. Although with passive scanning, there are possibilities for a lot of false positives, and it relies on the device to have an active data transmission state for data analysis to take place. These two types of scanners are the reason and the main motivation for them to take a look into a real-time network graphing tool on a protocol level, which will aid in having an up-to-date network graph for potential threats that could be interrupted with real-time data available at hand. Situational awareness is the centerpiece for the real-time solution. In most simplistic terms, situational awareness is the state where something is aware of its own state and reacts to changes accordingly once they occur. Simple diagram illustrates the concept in the following way. A new data for analysis being received. Information for potential changes is being gathered. If a change to the information occurred, then an action will be triggered, and that action can be anything. And if no changes was triggered, then continue waiting for new incoming data. Just the same way, a computer program is on a constant watch for an incoming data which may trigger different kind of events that can either start a new service, establish an unusual connection to an outside device, or transmit data using restricted protocols that administrators have set up, but somehow it was bypassed. It's a truly simple but powerful concept to include in the real-time solution. The proposed solution is as follows. It will be split into two separate applications, one for the client side and the other for the server side. It is different compared to the other active and passive scanners, where it's one centerpiece, which is for example, for the active scanner, it sends the packets to the network devices and then receives them back for analysis. And for the passive scanner, it will be again, one centerpiece that examines the network flow or network traffic. But in order to achieve the actual real-time solution, this is the reason why they'll be split into two applications. The client-side application development will be with in mind of situational awareness, meaning that the application will be running on each individual PCs that reside on the network and continue gathering the information around its own system. In this case, it will be just with the protocols and the services running on those ports. And once a new change will be introduced into the system, it will be sending it to the server, which will be rendering the graph. So the server-side application is the one that establishes the first connection between all the client-side PCs that have the application installed. And as a potential way of actually seeing an unusual device being connected to the network is that they don't actually respond, for an example, an API call to that client-side application that should be sending back the information of its own systems so that the network graph could be rendered. And that's the reason for the split of the two applications to achieve the real-time solution. So this is the high-level overview of the actual application and the entire system that's built. The server will be establishing a connection with all the PCs on the network running the actual client-side application, which continues gathering information around its own system, listening for the incoming new information data that might change any of that, or like trigger for new services to be running on the system. And the action will be to actually send that data to the server, which will be rendering graphs around like the network, and have the ability to select individual nodes that represent the PCs and examine the network on a protocol level, where we see all of the connections being done on different ports. The real advantage of the proposed solution is that each machine that resides on the network will be aware of its own environment and will store that information in a convenient way, which will allow to quickly send that information to the server, which will be rendering the network graphs, which essentially prevents any spoofing information and also achieves that real-time solution, because only if the change of the data occurs to any of the PCs, the data will be sent back to the server and update the graph, or it also can be done manually or have a set timer that if no data was received back in, let's say, 10 seconds, the server will ping all of the machines to see like what's their update status, and that achieves the real-time solution. The big disadvantage, of course, is the actual need to have that client-side application being installed on each individual machine. That's like an extra work for administrators, depending on how they actually deploy their machines. But also, like any device that is being introduced without this client-side application installed is going to be treated as a device that holds a potential threat to the network. And that is all for a real-time solution for graphing on a protocol level. Thank you.